Hello guys, I am Vipin Kumar and today we discuss the polynomials, which is the second chapter of the 9th class mathematics book. So firstly, today we do the polynomials in one variable. So firstly, I define what is polynomial. An expression of two or more than two algebraic terms that contain variables that are raised to non-negative integer integral powers can called polynomials. So what does mean? It means the any two or more than two algebraic terms that contain variable and rise to non-negative integral power are called the polynomial. Okay, so now we discuss the type of polynomial. Type of polynomial based on the number of terms. A polynomial can be classified into monomial, binomial, trinomial, etc. So what is monomial? So monomial is an algebraic expression having one term is called a monomial, like px is equal to 2x. Then there is a single algebraic term, then it will be a monomial. So what is binomial? And polynomial having two terms are called binomial and monomial. A polynomial having two terms is called binomial. And so for example, px is equal to x square minus 9x. So this polynomial having two algebraic terms with variable, so this is a binomial. Third, trinomial. What is a trinomial? Polynomial having three terms called trinomial. So like px is equal to x raised to the power 5 plus 9x raised to the power 2 plus 1. So this is having three terms. This algebraic expression having three terms and have the variable. So this is a trinomial. An algebraic expression of the form px is equal to c, where c is a constant. A constant is called constant polynomial, or the constant polynomial 0 is called the zero polynomial. So constant polynomial 0 is called the zero polynomial. So degree of polynomial. What is the degree of polynomial? So the degree of polynomial is the highest degree of its individual term with non-zero coefficient. The degree of a term is the sum of the exponent to the variables that appear in it. So simply, what is the degree? What is the degree of polynomial? The highest degree of that the highest degree of variable in that polynomial is the degree of the polynomial. Like px is equal to x raised to the power 4 minus x raised to the power 8 plus 1. So the degree of this particular polynomial is 8, because the highest degree of this polynomial is the highest degree of variable in this polynomial is 8. So that the degree of polynomial is 8. So for a polynomial in one variable, the highest power of the variable is the polynomial in the polynomial is the degree of the polynomial, like fx is equal to x square minus 9x cube plus 2x raised to the power 8 minus 6 is a polynomial with degree 8, because as the highest power to which x is raised is 8, because the highest degree of the variable in this polynomial is 8 here. So note some things. Notes: the degree of a non-zero constant polynomial is 0. It means the degree of a constant polynomial like px is equal to 3. So its degree is 0 because here the degree of the x is 0. The degree of the zero polynomial is not defined. The degree of zero polynomial is not defined. So now we classify the polynomial according to their degrees. So polynomial can classified according to their degree on the basis of their degree. Can firstly a polynomial of degree 1 called a linear polynomial, like px is equal to x minus 1. So this is the degree of this polynomial is 1 because the highest degree of the variable is 1. So this is a linear polynomial. Next, a polynomial of degree 2 is called a quadratic polynomial. For example, px is equal to x2 minus 4x plus 1. So the highest degree of the variable in this particular polynomial is 2. So this is a quadratic polynomial. Third, a polynomial of degree 3, a cubic polynomial is a cubic polynomial. For example, px is equal to x raised to the power 3 plus 3x plus 1. So the highest degree of in this polynomial of the variable is 3. So this is a cubic polynomial. So now we represent equation on the graph. So a polynomial can be represented on the graph. To understand the nature of the polynomial, it is zeros, etc. So we can represent the polynomials on the graph to understand the nature or its zeros or roots or its zeros on the graph, like px is equal to x plus 1. So this particular polynomial is represented on graph. To understand its nature, we can represent on the graph to understand its nature. So for example, geometrical zero of a polynomial are the point where its graph cut the x-axis. So there is an example where the geometrically zero geometrically zeros of a polynomial are pointed where its graph cut the x-axis. Okay, so zeros of polynomials, or we can also say the roots of polynomials. What are the zeros of polynomials? A zero of a polynomial px is a number c such that the pc is equal to 0. So it's mean if we take px is equal to x minus 1, so the zero of this polynomial is plus 1. if we take the x is equal to 1 plus 1, then here we plus 1 minus 1 is equal to 0. So p1 is equal to 0, then 1 is the root of the x minus 1. So there is an example like the 0 of a polynomial px is equal to x square minus 4 r2 and minus 2. If we put the minus 2 here, then square it. So if we put x square is equal to minus 2, then p x is equal to x square minus 4, sorry, x is equal to 2 minus 2 is, sorry, so then x square minus 4 is equal to minus 2 square minus 4. Then the minus 2 square is equal to 4 minus 4, then it will be a 0. So we can say that minus 2 is the 0 of that of this particular polynomial. Since p2 is equal to this is equal to 0 and p minus here it's shown that you can see. So not something, a non-zero constant polynomial has no 0, and every real number is a 0 of the 0 polynomial. Means every non-zero constant polynomial has no 0, no root, and every real number is a 0 of 0 polynomial. Means the zeros of 0 polynomial or the roots of 0 polynomial is every real number. So numbers of 0. How many numbers of 0 any polynomial has? So in general, a polynomial of degree n has at almost n zeros. Means a polynomial of degree 1, if there is any polynomial of degree 1, then it will be has at most 1 0. If the polynomial of degree 2, that at most it will be 2 zeros. So here a linear polynomial has 1 0, a quadratic polynomial has at most 2 zeros, a cubic polynomial has at most 3 zeros. So now we discuss about remainder theorem. What is remainder theorem? Or long division method to divide two polynomials. Now we discuss what is remainder theorem and long division method. So firstly, long division. To divide one polynomial by another, follow the step given below. So arrange the term of the dividend and the divisor in the decreasing order of their degrees. Like in this form, the divisor is x minus 2x square and dividend is x minus x square. So then we arrange it in the decreasing form. So 2x minus x and x square minus x. So at that time, to obtain the first term of the quotient, divide the highest degree term of the dividend by the highest degree term of the divisor. They carry out the division process. So to obtain first term of quotient, divide the highest degree. In the case, the highest degree, the figure is given below. In this case, the highest degree is x3. x raised to the power minus x raised to the power 3, and highest degree of this is x raised to the power x square minus x square. So divide this to take the first term of quotient. So the remainder of the previous division become the dividend for the next step. So we get this remainder, and this will be the dividend for the next step. This will be the dividend for the next step. Repeat this process until the degree of the remainder is less than the degree of the divisor. So we repeat this process until the degree of the remainder is less than the degree of the divisor. So the here the remainder is 3, so the degree of the remainder is less than the degree of the divisor here. So now we talk about is remainder theorem. When a polynomial fx of degree greater than or equal to 1 is divided by a linear polynomial x minus a, then remainder is equal to the value of fa. If fa is equal to 0, then x minus a is the factor of the polynomial fx. It means if we get a polynomial px is equal to x minus 4, x square minus 4, then we take x as then we take x square, then we take x is equal to, and take a guess, and I take the x is equal to 2, then apply it, then x square will be 4, so 4 minus 4 is equal to 0. Then this is the factor of the it will be the then find the then we get the factor of the px. So now we come to factor theorem. What is factor theorem? If px is a polynomial of degree greater than or equal to 1 and is any real number, then x minus a is a factor of px. If it is almost equal to the remainder theorem. Learn the definition and you can find out how. So now we come to factorization of polynomials. So now we do the factorization of polynomials. Factorization of quadratic polynomials. Now we do the factorization of and splitting the middle term. There are two methods, factorization and splitting. So firstly we do the factorization. Factorization of a polynomial ax square plus bx plus c by splitting the middle term is as following. Step 1. We can split the middle term by finding two numbers such that their sum is equal to the coefficient of x and their product is equal to the product of the constant term and the coefficient of x square. So here an example is given, like for example this term x square plus 5x plus 6. So by splitting the middle term we have to find the two numbers whose product is equal to the product of these outer terms and whose sum is equal to the 5x. So the product is 2x plus 3x, x square plus 2x plus 6. So here 2 plus 3 is equal to 5. 2 plus 3 is equal to 5 and 2 into 3 is equal to 6. So step 2, now we factorize by the pairing the terms. So now pair the term and factorize it. Like here we take the common x and in bracket x plus 2, then plus take the common, then x plus 2, then x plus 2 is a factor and x plus 3 is a factor of that term, of this term. Okay, now factorization of quadratic polynomials by factor theorem. So how we can factorize the quadratic polynomial by factor theorem? So to factorize a quadratic polynomial fx ax square plus bx plus c, find two numbers px and q such that pq and fp and fq is equal to fv is equal to fp is equal to fq and fq is equal to 0. Let us factorize the quadratic polynomial fx is equal to x square minus 3x plus 2. The first step, we take the f2, then x is equal to 2, then f2 is equal to 2 square minus 3, 2 plus minus 3 into 2 plus 2. So then it will be 4 minus 6 plus 2 is equal to 0. It means 2 is the factor of x square minus 3x plus 2. So then we take x is equal to 3, so f3 is equal to this, and this is equal to 9 minus 9 plus 2, which is equal to 0, and which is not equal to 0, which is equal to 2 and not equal to 0. So x minus 3 is not a factor of this polynomial. So now we take the 1, then now we take the 1 as x at the place of x, then f1 is equal to this, and this is equal to 0. So x minus 1 is equal to the factor of x square minus 3x plus 2. So there are two factors of this term x square minus 3x plus 2, which are x minus 2 and x minus 1. Algebraic. Now we talk about algebraic identities. What are algebraic identities? So there are some algebraic identities like a plus b whole square is equal to a square plus. These all are some algebraic identities which can help us to factorize some polynomials. These all are some algebraic identities. So you can note that and now there are two or more algebraic identities. This